Now, in a random sample of 200 students, 48 said they spent at least 1 hour each day watching TV. Write down the sample size. Sample size is 200. The more people that are in your sample, the more accurate your answers. That's a universal truth, right? What is the margin of error? The margin of error formula is 1 over the square root of n. So what do you think the margin of error is in this question? 1 divided by the square root of 200, okay? Which is 0.07, so roughly 7%. Is that okay? So, margin of error is plus or minus 0.07. I'll explain what that means in a second. What is the sample proportion? The sample proportion is 48 over 200. So 48 over 200 in decimals will give you what we're claiming is 24%. Okay? So 0.24 is 24%. Everybody cool with that? But our margin of error states that it actually could be 24 take away 7 or as high as 24 plus 7. So what sort of gap are we talking about here? Anywhere between 17 and 31. So you write your answer like this. 17 less than P less than 31. Is that all right with you guys? All right. So, all right, guys, write down the sample size, 400. Write down the margin of error, 1 over the square root of 400, which all you guys told me was 0.05 or 5%. Find the sample proportion. 136 divided by 400. 0.34. Yeah. Great. Now, this gets much easier now. And then, so 0.34, okay, and take away 5 and add 5. So what you get? 29 less than 0.29 less than P less than 0.39, is it? Yeah. Happy enough with that? Now, first thing I'm going to ask you is, in the previous question we had 200 people, didn't we? And the margin of error for 200 people was 0.07. So here's a question for you. When we doubled the amount of people we interviewed, did we halve the margin of error? Yes or no? When we went from interviewing 200 people to 400 people, did we double the margin of error? Or half the margin of error? No. So it doesn't work that way. If I interview 500 people and I want to half the margin of error, interviewing 1,000 won't be enough. You got that? It doesn't work that way. See, interviewing 200 people gives you a 7% margin of error, but interviewing 400 people gives you a 5% margin of error. You remember recently the news about the vaccine with Pfizer, Habil? How many people did Pfizer test? 60,000. Now get this, what's the margin of error for 60,000? 1 divided by the square root of 60,000. And that's a really, really, really small number. It's actually 1. I got it. It's 0.004. So the Pfizer margin of error is 0.004. So what Pfizer are claiming is 90%, is it? 95. They're claiming 95. So what they're claiming is 95. But then you take away, so they're claiming 0.95. But because they tested on 60,000 people, you get what I'm saying? You know what that turns into? It turns into 0.4946, because when you add on 0.04, it turns into 0.95. And then it also it turns into, yeah. Now, for argument's sake, imagine they only tested 20 people and says, oh, look, it's 95% effective on 20 people. Get this. What's 1 over the square root of 20? Somebody put in the calculator. They only tested 20 people. What? 0.22. Get this, lads. 0.22 is 22%. So if they only tested 20 people, it's 95 take away 22, which would be anywhere from 73. And then the next part would be over 100, which is impossible. So you'd have to stop at that. 100. But you see the way it widens the margin? So that's why you have to test lots and lots and lots of people.
Where they get the 6,000?
They just, a lot of people wanted to try it out. Like, they just wanted to be
So is this like
just all over the world, like Germany, America, you name it, they try.